Hello everyone, my name is Phoenix and in today's video we are going to solve our first CTF challenge from QuillCTF, which is road closed. For those of you who don't know what QuillCTF is a series of capture the flag challenges with varying difficulty levels. So without further ado, let's just quickly start with our first challenge. The objective of CTF is to become the owner of the contract and to change the value of hacked to true. We have provided with a contract code. For the ease of use, what I've done is I have pasted that into my local environment. We can see we have this contract, we have a boolean which we need to change, we have a mapping, we have a function called isContract which is checking the exit code size to prevent anybody from calling by becoming a smart contract. We have a function isOwner that is checking if message.sender is owner or not. We have a constructor. We have a function called add to whitelist, which is essentially adding any address to this mapping called whitelisted minters. We have a function called change owner, which after passing certain restrictions is changing the owner which we have defined in the constructor to the address provided. We have a function called pawn. This function is also have some require statements, and after successful execution of them, it is changing the value of hacked is true. We have another function with the same name. And at last, we have a function called isHacked. This function is returning whichever value of hacked is present at that moment. So in order to exploit this, we need a way to add ourselves into the whitelisted winters mapping, because that is what the restriction in change owner function is. The only way through which we can do that is by calling add to whitelist function. Since add to whitelist function doesn't have any particular restrictions other than this require statement, which is checking if the caller is a smart contract or not. If you are doing this on chain, what you can do is pass all your logic into the constructor and this check will bypass. But since we are doing this in our local environment, this check doesn't matter. So our attack process looks like this. We will first call add to whitelist function, which will grant access to this mapping. We will then call the change owner function to change the owner, and as soon as we are the owner of the contract, we can call this pawn function, which will make the our boolean to true. So I've created a test for the smart contract. I have done the necessary imports. We have a variable called road closed. I have also assumed an address called attacker through which I'll execute my process. I have also written a setup function to virtually deploy my smart contract. Now the test hack function will start by changing the caller address to attacker. Then we'll first call the add to whitelist function. Assuming that this function has been successfully called, we can call the change owner function. After that, we can call the pawn function. If all of this is successfully executed, the assertion which I have provided here, which is calling the isHat function, should return true. So let's just quickly start our test. We will write forge test. Perfect. You can see that our text hack function has been successfully passed, which means the assertion which we have provided holds true. With this, we have concluded the attack and have successfully exploited it. For more of these videos, stay tuned and subscribe to Quill Academy YouTube channel. Thank you.